Hi, this is Ryan, and this is my paper review number 2. So, for my paper review, I read the paper that was a systematic review of machine learning and sports betting. So, within this paper, they explored the evolution of machine learning in the sports betting world, specifically how over time machine learning has been implemented to increase the productivity and efficiency of sports betting and determining betting odds. So this paper kind of analyzed 219 studies across 10 different sports um, of different machine learning models within sports prediction. So this can be things such as game level to player level. And with this paper, they kind of highlighted the overarching themes across all the studies that help drive prediction modeling, sports forecasting, and player driven insights. So within this paper, they kind of focused on a bunch of different studies, but the main one I wanted to focus on was machine learning in terms of player prediction performance. Um, so when looking at prediction or performance prediction across studies, there were certain models that they found that were the most useful in terms of player prediction and kind of detailed why they were useful. So the first one was multitask regression. Um, with the study they kind of mainly focused on, they saw that they were trying to predict Bundesliga player ratings from event data, such as passes, shots, duels. And with this, they're also able to use that hand in hand with random forest and gradient boosting models to kind of handle the nonlinear interactions between player stats, their ratings, and potential consistency metrics or fatigue that player might have experienced or injuries. Another study they kind of delved in and saw did a well and accurate job at predicting player performance was the use of a neural network. So within the neural network, by using inputs such as not only just the performance of a player, but different talent identification metrics such as ratings and that sort of thing, um, that specific study was able to achieve a 70 to 80% accuracy. The last models that they kind of explored and saw useful were Bayesian models, which these Bayesian models kind of were able to integrate uncertainty in terms of a player's performance and kind of track real-time updates during games, such as injuries, stats, that sort of thing, to kind of handle and predict a player consistently across not just one game, but multiple games as well. So with this paper and the things I found from it, how can I can apply it to my capstone is the main one is feature engineering. There are lots of stats out there with just player level stats, but the most successful models that this paper found and I have seen in terms of the research I've done was the use of player level stats in conjunction with contextual data such as opponent stats, game factors such as weather, in order to get a comprehensive overview of how a player may perform. Um, Another thing I can apply are the modeling techniques listed on the past slide, such as gradient boosting or neural networks, to kind of create an ensemble model that could help account for the various variability of a player's performance, utilizing not only their player performance metrics, but also things such as opponent stats, contextual data, that sort of thing. And then, with all this being said, it's mainly applying it and being able to calibrate and evaluate my model by using various methods such as cross validation, residual analysis, and probability calibration to kind of track the predictions for a player's performance. So, yeah, that is my paper review. Thank you all for listening.